and in today's video we're going to have a little look at electrolysis. The first thing about electrolysis is that there's quite a few key words and it's fairly easy to get a little bit confused by the sheer amount of keywords. So I'm going to break them down and hopefully give you a little some easy tips to help you remember what each of the keywords mean. Now the first thing you need to know about electrolysis is what ions are. Now ions are charged particles. These can be either positively or negatively charged particles. So that's what an ion is. Now there are two separate words to distinguish whether or not it is a positively charged particle or a negatively charged particle. A positively charged particle are called cations. And the way that I remember that is, so cations are positively charged, and the way that I remember that is, I've got a cat, Saria, she makes me happy. They are positively charged particles. So cats make me happy, cations must be positively charged. And the other one is an anion. An anion sounds a little bit like an onion. Onions make you cry, therefore an anion must be a negatively charged particle. So just to quick recap, ions, charged particles, cations, cats make you happy, cations must be positively charged particles. Anion sounds a little bit like onion, so they must be negatively charged particles. Very, very quick overview of what ions, anions, and cations are. Now, if we have an electrochemical cell, and we set one of those up, it will look a little bit like this. So we have a beaker, and in our beaker or our container will have some form of liquid, and that liquid will be what's called the electrolyte, the thing that we are separating. Electrolyte spelled correctly. And in there we'll have two what called electrodes, not the Pokemon electrode, but two. So when you did this, or you're going to do this, you'll probably end up using graphite electrodes, which is just two rods of graphite, and you'll attach crocodile clips or attach it up to a circuit, and a current will go through it. So we'll attach our electrodes to a power pack, and this one can be in the positive one, and this one can be in the negative hole. Now this will then make our electrodes charged. Obviously then we'll have fancy names for our electrodes as well. So our electrodes will be called cathode and anode. And very handily, the cation will go to the cathode, and the anion will go to the anode. Now I remember looking back up, there are silly ways to remember what a cation and an anion is. Cations being positive, so they are positive, and our anion being negative. So because our cation is positive and being attracted to the cathode, that must make our cathode negatively charged, and therefore our anode being positively charged. Students tend to get a little bit confused, thinking that everything that begins with cat must be positive, and then everything beginning with an must be negative, which is not true. Anion is negative, cation is positive, and if positive is going to be attracted to negative, which means that the cathode has to be negative and the anode has to be positive. And our electrolyte is just whatever it is that we're separating. You probably would have done copper sulfate solution. Probably. The next bit that I want to move on to are the products of electrolysis. We'll start off with molten. So when it's gone from a solid and you've melted it down to a liquid, because that's slightly easier to get our heads wrapped around. So if we, for example, if we are electrolyzing some lead bromide, and let's move up. So we're electrolyzing lead bromide. So that's our electrolyte. The only things that are going to be if we melt down some solid lead bromide is lead and bromine. So our only possible charges, our only possible ions that we'll have is a lead ion and a bromine ion. Our lead with our positive charge, this must mean that this is our cation, and because bromine has got a negative charge, it must be our anion. And going back up to this one, we know that our cation must go to our cathode, so if we're electrolyzing lead bromide, the thing forming at the cathode must be lead. So at the cathode, lead will be formed. And if you're asked why that's the case, because the cathode is negatively charged, the lead is a positively charged ion, so it will be attracted to the negatively charged cathode. And likewise, bromine will be formed at the anode. Bromine will be formed at the anode. And then there's one last thing, that this is only a higher thing, but you also need to be able to do half equations. So it's basically what's happening at both electrodes. So at the cathode, lead will be formed. So we've got lead 2+. Now to form a lead atom, we need to gain an electron, which I represent with an E-. However, lead's got a +2 charge, so I must gain 2 electrons to form lead. And at the anode, bromine will be attracted towards the anode because it's got a negative charge, and it will form bromine. Now bromine, because it's part of group 7, the halogens, it wanders around as a pair, so it'll actually form Br2, which means that it's already unbalanced because I've got one bromine here, I've got 2 bromines here, so I need to put a big 2 in front of my bromide ion. However, that now means that I've got 2 negative charges, so actually it needs to lose not just 1 electron, but actually 2 electrons. So the foundation, you'll be asked what will be formed at the cathode and the anode. In our case up here, lead, Pb, is the cation, therefore will form at the cathode. And bromide is the anion, so bromine will form at the anode. The higher lot, you have to be able to do these half equations as well. So what I'll do is give you a puzzle for you to do yourself. Remember, this is molten, so this is only when it's when the ions present are the only ones that are because this is molten, this is the compound in a liquid state. So if I give you calcium, let's go calcium fluoride. So if you pause the video and have a go yourself, and then we'll go through it together. Okay, so the ions that I will have is a calcium, a 2+, and I will have a fluorine ion as well. The calcium is our cation, so at the cathode, the calcium will form because it's our positive charged, and at the anode, our fluorine's going to form. Fluorine. And for those of you doing the higher one, or the higher test, higher tier, you need to be able to do half equations. So we've got calcium, which is 2 plus, calcium 2 plus, and that needs to gain an electron. But remember, I've got 2 plus here, so I need to gain 2 electrons, which will give me calcium. And for our fluorine, it's got a minus charge. It's going to form F2 because it's a group 7, runs around in pairs. So I need to have 2 fluorines here, and I need to lose 2 electrons. The next little bit is if we've got an aqueous solution, and this is where it sort of steps up a little bit, and it'll all depend on the reactivity series. I'm not going to go into reactivity series this video. This is more looking at electrolysis and the products. So if we take our copper sulfate, because we've done that, copper sulfate solution, so I'm going to represent that with an AQ. That just means it's dissolved in water. And then I start listing all of our ions that are going to be present in our copper sulfate electrolyte, so that thing that we are trying to separate using electricity. So I will have copper from there, and I'll also have a sulfate. That I've just got from my copper sulfate. However, because it's dissolved in water, it's aqueous, dissolved in water, it also means that I've got H plus and OH, which is water, H2O. H2 and then O. So that's where the H plus and the OH minus comes from. Now at the cathode, it all depends on what metal we've got. If our metal is more reactive than hydrogen, then hydrogen will form. However, if our metal is less reactive than hydrogen, then the metal will form. Because copper is less reactive than hydrogen, then copper is going to form our cathode. So again, in this one, cathode, we're going to have copper. At our anode, so with the anode in an aqueous solution, if there is anything in group 7, then the halogen, the group 7 element, will form. If there's nothing from group 7, then what you get is oxygen and oxygen being produced and given off at the anode. So do I have anything from group 7? No. I've got sulfur and oxygen, both in group 6. None of them in group 7. Therefore, oxygen is going to form. So at the anode, oxygen will form. And again, for those of you doing high, you need to be able to do half equations. So with copper is a 2 plus. So Cu 2 plus, and that's going to have to gain 2 electrons to become copper. So I'm trying to cancel out that 2 plus there. However, at the anode, you have this OH minus forming oxygen and water. However, I can already see a little bit of an imbalance here, and some electrons. This has to be balanced, because otherwise it doesn't make any sense as a chemist. So I can already see that I'm going to need, if I put a 2 in front of there, which gives me 4 hydrogens and 4 oxygens, so I have to put 4 there, which means I've now got 4 minus charges, which means I'll have to have a 4 in front of the electron. If I give you one, you can have a go at it yourself. if I give you sodium sulfate, you can pause the video and you can have a go at one yourself. And I'm going to quickly go through this before my battery runs out. So, is our metal more or less reactive than hydrogen? It's more reactive, so at the cathode, hydrogen is going to form. And at the anode, is there anything from group 7? No, which means I'm going to have oxygen. Half equation for the hydrogen, we're going to have H plus nu minus will give us H2, which means it's unbalanced, so I need to have a 2 there and 2 there. And with our oxygen, it's the same as up here, so 4 lots of OH minus gives you O2 plus 2 lots of water plus 4 electrons. Sorted. So this is one of my 2 giant Madagascan deer geckos. This is Solaire, and in the other enclosure there is Gwyn. He's in a slightly smaller enclosure because I had a little bit of a mould outbreak. It's very upsetting. So I'm in the process of fixing him. So he's not particularly happy with me. Don't really handle these very much, which is why I'm not sticking my hand in there and getting on my arm or hand, because Solaire will just run up and down my arm and jump all over the place, and Gwyn will run and hide away from me. Their skins are slightly too delicate, so not a handling species, but very, very, very lovely. Possibly one of my favourite pets that I've got.